And they're asking the question, is that a reasonable ratio? And they show in the table arm and nose lengths of 18 girls in a statistics class. Okay, so they took 18 girls in a statistics class, they measured their arms and they measured their noses, and they have these arm to nose ratios for all these kids. Now, it gives you all the arm lengths, and it gives you all the nose lengths. We don't care about the arm lengths, we don't care about the nose lengths. All we care about is the arm to nose ratio. I don't care about those first two columns for this question. So there's a little bit of data thrown in there that is superfluous. So they're asking me to make an appropriate plot and describe the distribution of the ratios. They're asking me to summarize the ratios numerically, choosing appropriate measures of center and spread. And they're asking, is the ratio of 9.3 for the Statue of Liberty unrealistically low, and explain. This is the kind of problem that you're going to have on the test, where it's going to cover a lot of different points. I mean, a problem like that, I could find like 20 different points that are there, so that when people give me an answer, I can give a lot of partial credit. Does it make sense? This is a complex problem, but a thinking problem. So I'm going to put in the arm to nose ratio of the girls in the statistics class into the computer. So into the calculator. So you might want to do the same thing. I got 14.8, 16.4, 15.4, 13.3, 15.6, 13.4, 14.2, 14.4, 11.8, 14.6, 15.3, 16.4, enter, 16.9, 15.9, 15.7, 15.5, 14.8, and 15.2. Okay, so yeah, so I got in all my 18 data points there. And so what I'm going to do, the first thing it asks me is, it says make an appropriate plot and describe the distribution of the ratios. So I have these ratios that are in my calculator, and I want to describe the distribution. I'm going to make a histogram. That's where I'm going to start. I'm going to start with a histogram. So I'm going to go second stat plot. And I have a couple plots on because I was messing with it earlier, and I don't want to get errors and dimension errors, so I'm just going to start. I'm going to clear out all my plots. So I'm going to push 4, which says plots off. I'm going to push 4, and it says plots off, and I'm going to push enter, and it's done. So now I go back to my second stat plot, and all my plots are cleared out, so I know that I'm not going to have any conflicts with other plots. Does that make sense? Right? It's a good thing to do on your calculator, that you avoid these dimension errors, which cause panic and distress. Okay. So plot number 1 is the one I'll use, and I'm going to first turn it on. So I put it on, and now I'm going to go to the type, and I want to start with a histogram, because that's kind of like my basic diagram, and I have the blinky thing on the histogram thing. I'm going to push enter, and the list I'm going to use is list 1. So I'm going to go second 1, I'm going to use list 1, and I'm just going to start with whatever the calculator decides to give me by going zoom 9. Whoops, I can't do it. Sometimes it doesn't like me to do it. So I'm going to go zoom 9. And I got a histogram. Okay. Well, I'm actually kind of pleased with that histogram. Why? Why am I pleased with that histogram? Yeah, I mean, that looks unimodal and symmetrical, more or less, right? So I said, oh, goody. I'm going to be able to use a normal model to answer this question, which, by the way the question is phrased, I can see that that's what they're going to be asking me anyways, right? Because the question is saying, you know, is the Statue of Liberty's nose to arm ratio reasonable or not? Well, you know, I mean, is it going to be an outlier? Is it going to be, what's the Z-score going to be? Those are the things that are going to help me analyze this. So I'm really pleased to look at my histogram, and I say it's a normal histogram. And so then it asks me, make an appropriate plot and describe the distribution of the ratios. Well, there's an appropriate plot, and I'm going to say, well, it looks unimodal and symmetric, shape, center, spread, right? It's shape, it's unimodal, I'd say the center, well, I don't know what the center is yet. So I might go trace and see what my values are here. So my min ratios are 11, my lower ones are 11 to like 13, and then I go up there, it's like, you know, not quite 13 to not quite 14, and then I have, so somewhere between like the high 13s and the low 15s. So somewhere between 13 and 15 looks like it's my center. Do you see what I just did there? Right. We'll find another way to find that in just a minute. But so I'm looking for shape, center, and spread, and nothing really looks unusual about it to me. It looks pretty reasonable to me, so I don't have any unusual features that I would necessarily comment on. Okay? So, let's see here, 21. Summarize the ratios numerically, choosing appropriate measures of center and spread. Very important words there, choosing appropriate measures of center and spread. So I have a histogram that is unimodal and symmetric, right? So what are going to be the measures of center and spread that I'm going to use? We have two choices. We have median and IQR. Those two go together, right? So I'll write that down here. Median and IQR, those go together. And mean and standard deviation go together. Which of these is going to be more appropriate, do you think? Anyone want to venture a guess?
Median.
I will say median.
Okay. So when I have a distribution that is unimodal and symmetric, it means it's okay. Go ahead. What?
I was going to say median standard deviation because can't you use a normal model?
That's exactly right. That's exactly right. The normal model gives us more information than say a box plot. The normal model is really nice because amazingly enough, data in the real world tend to fall that way. I mean, and it gives you all this extra information that you can't get from IQR and median in a box plot, right? I mean, sometimes you just have to settle for IQR in a box plot because you know your distribution is skewed or it's bimodal or whatever reason, you know. But if you have something that is unimodal and symmetric, you're supposed to like get excited, you know, and say, oh boy, I can use a normal model, right? So so if you can use a normal model, you're going to have mean and standard deviations. Gives us a lot richer tools to use to analyze this stuff, right? Unimodal and symmetric. I'm going to want to use my mean and standard deviation. Does that make sense? You sure? Question on that? No? Okay. So I need to give an appropriate numerical summary. So I'm going to go. I'm going to quit this. Second, quit. Okay. I don't want mode. I want to quit. Go away. Okay. I'm going to clear my screen, and I'm going to go stat. Remember this important one, right? I'm going to go stat, and I'm going to go to calc, and I'm going to push 1 for variable statistics. And it's going to sit there on my calculator blinking at me, and I'm going to say, oh my goodness, what do I do next? Right? It's saying, what do you want the variable statistics for? Well, I want my variable statistics, it happens to be for list 1. So second 1, variable stats for list 1, push enter, boom, all this information, right? The top one, the X bar, is our mean. So I now have a mean of, well, 14.97. And standard deviation is the SX. So my standard deviation is 1.25. So those are some very good statistics to have when they're asking me for some appropriate numerical statistics. Because I know I have a normal model. If I didn't have a unimodal symmetrical distribution, these would be not that important. Okay? But since I do, those are important. So I'm going to take those two, and I'm going to add to those two my 5-number summary. I mean, it doesn't hurt to tell that I have a minimum of 11.8, a Q1 of 14.4, a median of 15.25, a Q3 of 15.7, and a max of 16.9. Those are good things to know. Right? fill out the answer as much as we'd like. So we can add to that mean and standard deviation. So instead of a 5-number summary, you now have a 7-number summary. And one of the nice things that you can point out if you're writing about this is you can say, oh, isn't it nice that my mean of 14.95 is really very close to my median of 15.25. Those are very close, indicating again that yes, it is a unimodal symmetrical distribution. Questions? Yes, please.
The answer sheet just gave out the median, the mean, standard deviation, and that's it. But like, is it better to just give the 5-number statistics, like just bars?
Yes.
Okay.
Yes, I think it is. I didn't look at the answer on this one, but yeah, I mean, because well, I'll show you why in just a second here. So, so I would give I would give all I would give 7 numbers of statistics. I mean, you know, it's not like they're hard to calculate. They're right there for us. But the key thing here in this question is choosing the appropriate measure of center and spread. So you definitely want to say, because I have a normal distribution, my mean and standard deviation are the appropriate measures of center and spread. I want to be able to see that you know that those are more appropriate than the median and IQR. Okay? Yes?
When would it be median and IQR?
If the distribution is not unimodal and symmetric. So if I have a skewed distribution, I want to use median and IQR, because mean is irrelevant. Does it make sense? Okay. We okay with that? Okay. Very important.
Can you repeat that one last time?
Absolutely, I can. Okay. Okay. So the question is asking, choose appropriate measures of center and spread. I have 2 measures of center and spread here. I have median IQR, right? Center, spread, and I have mean and standard deviation. Those are my 2 measures that I can use. Right? And mean and standard deviation are only appropriate for normal models. In order to have a normal model, it has to be unimodal and symmetric. If it's bimodal or if it's skewed, mean and standard deviation are meaningless. Do you remember why mean is mean? Did I do the? Maybe it was the other class. So if I have a distribution with 5 data points, 1, 3, 5, 7, 9. What's my median? Right? Right? Everybody see that? That's my median, right? And what's my mean? I think it should be 5, right?
Yeah.
Right? The mean is also going to be 5, right? Did everybody see that? Okay. So now I want to change my last number from 9 to 90. What's my median? My median is still 5, right? What's my mean? I don't know, something like way over, 87 or something, right? Right. So the mean becomes a much less meaningful statistic if my data is skewed. And this would be a very skewed data, right? Because I have this 90 like hanging way out there. Outliers and skewed data make the mean not that relevant. Okay? So that's why when I have skewed data, I want to use median and IQR, because if I'm looking for a center, the median gives me much more information. Okay with that? Okay. So I give 7 number statistics, and but now the other thing that I'm going to do here is I have the data already in there, so I'm going to go back to second stat plot. Second quit. Okay. So I'm going to go back to second stat plot, and I'm going to go to plot 2. I'm going to turn it on. I know I have 2 plots going at the same time, but I'm going to plot the same data. So that's okay, because I'm going to have my graphs are going to be the same scale. So I'm going to go down here to a box plot. Got my box plot icon blinking, and I want to use the box plot with the little dots because it's going to show me outliers. Okay. So I'm going to enter that, and the list I'm going to use is L1, because that's where my data is. Okay. And now I'm going to go zoom 9. why it does that way, but it does. Zoom 9. And now I have my histogram, and I have my box plot just overlaid right on top of it. And the reason I did that is because I'm going to go trace. And the first thing it's tracing is my histogram. You see it's on the histogram? And I want it to trace the box plot. I want it to trace the box plot, I said. Oh, I have a Y value in there. That's my problem. Okay, figure that out. Zoom, 9, trace. I want it to trace my box plot. And you see it starts right there on my min, right? And then I can go to my Q1 and my median and blah, blah, blah. But I'm going to go over here to the left of my min, and because I saw that I had this outlier sitting over there, right? And that outlier is at, that's actually my min. My outlier is at 11.8, right? So I have a very low outlier. Can you see that? Right. What is the ratio of the Statue of Liberty's arm to nose ratio? 9.3, right? So, but I already have an outlier, a low outlier at 11.8. So where's the Statue of Liberty going to be? The Statue of Liberty is going to be like way over here, right? Right. So I've answered the next question. Is that appropriate? Is the ratio of 9.3 for the Statue of Liberty unrealistically low? Yeah. I mean, it's an outlier like you know, maybe even a little star outlier as opposed to a little circle outlier. I don't know. You don't need to calculate that, right? But so it's way over there, right? So that's one way that I could say, well, yeah, that's an outlier, and you know, it is unrealistically low, right? There's another way that I could determine that it's unrealistically low, and I could calculate the Z-score. So I want to know the Z-score for the Statue of Liberty's nose, arm to nose ratio, right? So the Z-score for the Statue of Liberty's arm to nose ratio, Z equals Y minus Y bar over S, or Y minus mu over sigma, same thing. So my Z-score, her arm to nose ratio is 9.3, right? That's my data point. Right. My mean, if I recall properly, was 15.25 because it was a normal model. That was a statistic. Was it 15.25 or was it 14 point?
14.95.
14.95. Can we round it up to 15?
Sure.
Okay. So my Y bar is 15. And my standard deviation. What was my standard deviation? I'm going to go back to
1.25.
1.25. Thank you. You had that written down. Okay, 1.25. So what is my Z-score for the Statue of Liberty's arm to nose ratio?
Negative 4.56.
Negative 4.56.
Wow.
Z is equal to negative 4.56. So not only is the Statue of Liberty an outlier, the Statue of Liberty, she is off the normal curve. Right, because our normal curve stops at negative 3, right? I mean, it actually goes to negative 99, you know, in the cafeteria. But so you have two methods there to show why the Statue of Liberty's ratio there is way off. Any questions on this problem? Did it answer every question you have, Morgan? Yeah. Is that like more information you wanted to know?
No,
No?
not really.
It was good. Okay. All right. All right. All right. So we're good with Statue of Liberty here.